off. Can we see drone taking off in the simulation? Amazing. You see, when the drone was taking off, when the drone is taking off from the simulation, it had some lag. It just came to left. This means the motor frame should have some modifications. Maybe you can change the PID values or use better Kalman filter to reduce the error. Now, when I touch this, it goes to position mode. You can see here it says position mode. So now I can basically run this. Hi everyone. Today I have brought my X500 drone to park, and I'm going to show you the software and hardware in the loop simulations. As you know, robotics testing is really expensive, so we use simulations to predict how our algorithms is going to perform in advance. This is especially crucial in UAV industry because a lot of things can go wrong, and by analyzing your flight logs, you can modify your parameters and configuration files in a way that can perform in their best form and prevent accidents. So first I open my ground control station. I'm going to show you my setup afterwards. First I'm going to show you the HITL testing. Now currently as you see, airframe is chose as hill configuration. So let's see what are the errors. Now one of them is probably it's happening because the GPS is going to fix in a few seconds. It would be connected. Then I have my FlySky i6X. I have my FlySky i6X model. I'm going to connect this. Now, what you need to know is that in PX4 1.16, they have categorized the software in simulation. One is SIH, which is software in hardware. Basically, this means you are simulating the model from the mathematical model of the drone, the flight controller, and the other one is hardware in the loop, which is HITL. So I know this might sound confusing, but I'm just going to say it very brief and simple. In HITL, hardware in simulation, hardware in the loop, the details, the configuration files and airframe geometry is coming from the flight controller, and the sensor values, they're all coming from the telemetry from the flight controller itself. In software into loop, there is no connection whatsoever to drone itself. This is basically the examples that you are doing from the PX4 documentation. Okay, now we use Q ground control to change the airframe type. As you see, as you see in here in the airframe, it's saying SIH quadcopter, software in hardware. Now, if I want to show the simulation itself, we have to close the Q ground first. So I'm going to close it. Then I'm going to open my Pixhawk folder, open a terminal. By the way, you can check this blog, which explains the fundamental concepts behind software in hardware, how it's actually working behind the surface. In here, I'm going to start JMAFSIM first. So JMAFSIM is the simulation engine that we are going to actually use. In here, it also explains the logic for the flags that we have used. For example, the Q is actually letting the communication to work with Q ground. Okay. After JMAFSIM is started working, then in the other terminal, we start Q ground again. The order is actually important in here. First, you have to run the simulation, then the Q ground. In this way, JMAF sim will use UDP protocol to connect to Q ground.
Manual flight mode.
Okay, great. One more thing that just came to my mind, it's worth knowing. In the configuration part, there's a safety. In safety, as you see, there should be placed. Just a sec, I'm going to find this. Just at the bottom, it says hardware in the loop simulation. You have to make this enable. This is important. Otherwise, it wouldn't work and give you error. Great. Now our simulation is connected, Q ground is connected. You see I'm not getting error because my RC is also connected. I can get the transmitter data. Let's say if I say take off, can we see drone taking off in the simulation? Amazing. You see, when the drone was taking off, when the drone is taking off from the simulation, it had some lag. It just came to left. This means the motor frame should have some modifications. Maybe you can change the PID values or use better Kalman filter to reduce the error. Now, when I touch this, it goes to position mode. You can see here it says position mode. So now I can basically run this. Come up, left. Now, even if I'm not touching anything, I put my joysticks at the middle, but still drone is moving. Why? Because of the wind speed. Let's try something. If we put this in the altitude mode, or just a second, should be on hold mode.
Hold flight mode.
I think it's more stable right now. You see now it's not changing. It's because of the mathematical setup that's been integrated to the hold flight mode. Now let's change it to HITL mode. So first I'm going to close the JMAF sim. We are not going to do anything with the simulation. Just like the last step.
Communication lost on primary link.
Okay.
Switching communication to secondary link.
From the UDP it changed to the serial link because I'm connected with USB now. Anyway, vehicle configurations, we are going to airframe, and in here there should be disabled while vehicle is armed. Okay, so we have to change it to disarm the. Now, in normal flight you shouldn't do this because it would fall off. First you have to land, then disarm it. But this is just simulation, so it doesn't really matter. We go to configuration, airframe. This time we are choosing HITL. Okay, again we have to apply and restart. Now this time I have changed the setup to HITL simulation. The process is exactly the same what I show you in the video. What you need to remember is that software in hardware is acting as telemetry monitor, but in HITL the QGCs actively serve as a communication gateway between the flight controller and an external 3D simulator. Okay, this time also I'm driving it. I've changed the position flight mode. I'm going to top, going to right. Thank you for watching, guys. As you see, I have got my logs both from hardware in the loop and software in hardware. In next video I'm going to show you how you can analyze your flight logs. You can even do this in software in the loop practices as well. By gaining experience and getting to know, understand and learn this stuff, you can modify your parameters and algorithms to have to prevent from crashes and improve your flight times. Cheers.